Good morning and welcome everyone to, my first ever live broadcast on the SANS Blue Team webinars and online forums. My name is Mark Baggett. It is my pleasure to be here today. I am the author of SANS SEC 573, Automating Information Security with Python. And soon, hopefully, the new SEC 673 automating course, which follows up on 573 and talks about some more advanced concepts in automating Python. So my course, 573, is all about the development of information security tools. First, we assume that you don't know how to do any coding, and then we're going to, from there, teach you the basics of Python and then the practical application of those concepts in defense, in offense, and in forensics. And as we walk through and we build a lot of very simple information security tools and work our way up to building more complex ones, one of the questions that I often get asked by students towards the end of the class is, hey, I want to start to use these newfound skills to apply these concepts to various online open source projects. So how do I use GitHub? How do I use Git to make contributions to open source security platforms and different projects that are out here to really leverage these new Python skills? And I'll often do this. What I'm about to do here is a demonstration kind of for students in the morning, right? We'll have office hours before class starts, and I'll walk through and do some demos. But there really isn't an opportunity to get into this subject in the course material. So I really think that this is a great forum and a perfect opportunity to be able to provide additional content beyond what we are able to cover in the class, and that is how to do the practical application. So hello, everyone. Good morning to those of you who are joining in. So we're going to walk through a couple of live demonstrations here. Really, the whole broadcast, there's no slides. We're just going to go through live demo and talk about how we could use GitHub to do some contributions to open source projects. So first, let's create a directory here. I'm going to make dir. I'm just going to call it git demo. Now, I'm going to be showing you various git commands, right? So commands are like git init. Git init will initialize this direct. I want to change into my directory here, git demo. That's the other thing, is it'll be a live demo, so I'll make some mistakes along the way, for sure. All right, so here on, I'm going to go ahead and create a directory, or create a directory. Now I'm going to initialize it with git init. Okay. And what git init does, it basically says, all right, that directory that I'm in, I want to start tracking the progress of changes that I make in this directory. Now, we'll get to the part where we're going to start contributing to open source projects. But before we jump into that, I want to show you what the different statuses are, or status I, of files that we have in a directory can be. So we'll walk through a little bit of just some local things to understand how Git tracks files, and then we'll move into how do we get this stuff from the web. So I get the question, will we get this recorded in SANS webcast library? I'm not sure. Stephen, do you know if these are being posted to the webcast library? I know they're going to YouTube, LinkedIn, and all kinds of places. I don't know if they're archived for sure in the webcast library. Stephen, do you know? All right, we'll get that answer for you soon. Okay, so here in this Git directory, I've just done a git init. And what git init does is it says the directory that I'm in, it's the directory where I want to track changes. Now in this directory, I don't have anything there. There's nothing there at the moment, but I'm going to create a file. It does create this little .git init folder where it's going to record all the changes and keep track of the changes that you're making in the system. Let's go ahead and create a file in this directory. So I'm just going to echo a new file. And I'm going to create, I'll call this new file.txt. Okay. All right. So now I've got a directory in that system. And if I now use the command git status, right, Git will tell me what it knows about this particular directory and the files that have changed in it. Now, as I said, don't focus so much on the commands, git status, git init, and those things. We'll look at a graphical user interface that'll make those kind of things easier. But what I want you to see here is I've got this file in here, and initially, any file that you've got in a directory, Git considers it to be an untracked file. So it's not recording when you make changes to the file. It's not going to record if you delete the file. The untracked files are basically things that Git is not paying any attention to. It knows that they're untracked, but it's not going to do anything with it. When I want Git to begin to, well, track changes to a file, then right here it tells me under the untracked files, hey, you can use git add and then a file, and then that file will begin to be tracked. So let's go ahead and do that. It's like git add, and then we'll add new file.txt. And then I'll do a git status. And here I can see that that file has changed from a status of, well, untracked to a new file. So it knows that it's a new file that's been added to the system. Now, what I want to do now is I want to then take this new file and commit it to this Git repository. Now, when you do a commit, you can think of that as like a snapshot, right? A snapshot of the directory at that point in time, so that we'll know exactly what the statuses of the files were. Now, you could use Git on directories that have Word documents and PowerPoint. So if you wanted to use revision control on those types of documents, you could. But really, what Git is best at and is designed for is text files. So for making changes to software and things like that. Okay. All right, so let's go ahead and make this snapshot of this directory with this new file in it. So the way I'm going to do that is I'm going to say git commit, and with the commit message you get with commit, you got to give it a message, some type of an explanation of what this snapshot is going to be called. You can think of it as a snapshot name, right? So I'm going to call this added the new file. And there, I've done this now. Since this is the very first time I've run Git on this machine, I have to first configure an email address and a username to go along with my commits. And so here it tells you the commands that you need to run in order to do that. It says git config. So let's go ahead and run those. Git config -- global user.email, and I'm going to put in my email address, mbaggett@sans.org. And then I'm going to do git config -- global user.name, and then I'll put in my username that's on GitHub or whatever else. All of these things here are just being used to record who made the snapshot. It's more like a log, so it's not being used for authentication, or they don't even have to be valid email addresses. You could put anything you wanted to here, but I'll put my name here that as it appears on GitHub and Twitter and other places. All right, so now that I've done my git config, now I can press my up arrow again, and I'll run that git commit one more time. And so now I've got this new file has been committed to my local system. So now I'm going to do a Control L to clear my screen, and I'll do a git status. And so here I can see that, well, I'm working on a branch and that it's clean, right? There's no changes that have been there. So right now, that's telling me that this directory with snapshot has this matches exactly what's in the snapshot, that there's have been no changes. Okay. But now let's change the file, right? So let's vi new file.txt, and let's come in here and let's make this a newer file and save it. So if I do a directory, I can see that the file size has changed and it's a little bit bigger. And now let's ask Git its status again. So Git status. And if I do Git status, now you can see that the file has been modified. So it knows it's modified. Okay. So Git recognizes that. Now, so our statuses so far are untracked, and then you've got tracked, but let's see. I would have tracked but not modified. Let's add another file here. No, actually I'm not going to do that. Let's continue with this, watching this new file. Okay, so right now it recognizes that there has been a change to new file, but I haven't committed this to my snapshot. If I wanted to, I could revert back to that snapshot and go back to those other systems with some Git commands that we'll talk about later. But at this point, I can see that that file has been modified. I can also do things like git what changed. Okay? What git what changed does is it shows you your revision history. It shows you what has happened on your system. You'll see that git what changed tells me that, all right, in my snapshots, I've got this one thing called new file. So to really understand what's going on in a directory, I could look at what's changed. It'll show me the commit history, and then I can look at git status, and that shows me what's happened since that commit history. But git status is showing me that that file has been modified. All right, so let's say that I now want to, well, make that change that I just made to that new file a permanent change. Also, let's do this. I will git add new file.txt. And so now I'm adding this new change that I've just added. I'm going to do a git status. Here I can see that it went from modified and red. Notice that the status here was changed, not changes, not staged for commit. Down here, it's changes to be committed. So it went from a red new file that was not going to be committed to a change to be committed. So now what I'm doing when I'm adding these things back up is I'm adding some new files that I want to put into another snapshot, into another commit. So this new file, I'm ready to commit it. So what I could do is, now that I've got this, you could think of this is in its staged, right? This is now staged and ready to be committed to my local snapshot. I can now make a commit here and make that change. So let's do that. Let's say git commit -m, and then I'm going to call this updated new file.txt. And now git status. I can see that, let's see here, git commit -m. I've now made that change. I probably should have done a git commit before I did that, show you that I had a git that was ready. But right now I'm back to a clean status, so all of those things have been changed. Now, some other things I could do is I could create a new branch on my local GitHub repository. So what I could do is I could say something like git branch -n, and I'm going to create a new branch, and I'm going to call this, I'll just call it new branch. Okay. Git branch -n. What did I type wrong there? Git branch. Sorry, it's -b. N is not new. -b creates the new branch. Git branch -h. Let's look here. Git branch. Git branch. New branch. I'm doing right. Git branch -b new branch. What is it not doing that? Git branch. Git branch -b new branch. Okay, I'm not sure why that's not doing that. That should create a new branch. All right, I've obviously forgotten how to create a new branch. So I'm going to go over to Google. I'm going to try git branch new branch. Okay. All right, let's see. Git branch. You should be able to do it with git branch. I'm pretty sure. Let's check out. Git checkout -b new branch. All right, this will create a new branch for me. All right, so this is that only did that switch to my new branch, but it also created the new branch. Yeah, thanks. So git status. Now, if I look at my git status and I do git branch -l, and I can see that I got this new branch. And you can see that it's highlighted in greens, which means I'm working on that branch. So now the changes that I make in this branch are going to be actually tracked separately. So let's say that in this git branch, I do things like, let's first do a git status and see what our status is. And it says, all right, I'm working on new branch. I've got nothing changed. All right, so let's do this. Let's del new file.txt. It's rm new file.txt, and I've removed that from the local hard drive, but I haven't removed it from the snapshot from their repository. So let's do a git status. When I do a git status, I can see that that file has been deleted. So it recognizes it's been deleted, but it's not tracked it's not committed to my Git repository at this point. So let's go ahead and do that. Now here I can see that it's either git add or git rm if we want to update these changes. So I'm going to do a git rm new file .text, and then a git status. I can see that it's now been deleted. It's ready to commit that change to the hard drive. So let's commit it. So git commit -m delete new file. Okay. All right. And so now if I do a git, if I do an ls, I do a git what changed, I can see the status of the various the various commits that I've had in this directory, and I can see the names of the things. This is what where those comments go. That with the -m, that it's showing you what you've actually called your commits. And if I here do an ls, I can see that file is gone. Okay. Now, interestingly, right, what's actually happening here beneath the hood is that Git is actually rewriting things to the hard drive. So let's say that let's git git status. Let's git check out the master. Okay. Now I've switched back to the master branch. If I do an ls here, you can see that the file is back. Git check out the new branch. Git ls. You can see the ls. You can see the file is gone. It has nothing to do with this directory that I'm in, right? If I was to come over here to another file and just do an ls, I can see that the file has changed on the hard drive. And then when I check out new branch, do an ls, it's gone. And then when I check out master, it's back. Okay. So it's actually rewriting those changes. And what it's doing is it's grabbing the information that's in this Git folder, right? ls-l, this Git hidden folder that's in there, that's tracking all of those changes. And so you can see what's being recorded. So it's actually making those file changes. Okay. All right. So as we make changes to the file system, it'll go from a stage of modified but not staged to, and then we do a git add and it becomes staged, and then we can commit these things, and then it becomes part of a new snapshot of a directory, if you want to think of it that way. All right. But so with those statuses in mind, let's talk about, well, how I would contribute things to an open source project. Okay. Let's say that I wanted to make a change to Security Onion. So we got here to Security Onion's website. I've just pulled up their GitHub page. And I'm going to need their URL that's here, that's associated with GitHub or with Security Onion. Now, first thing you should probably look at if you're going to think about making a contribution to an open source project is look for a file called contributing. Usually open source projects that are open to contributing, there'll be a contributing.md file that's there. You can click on that, and they'll talk about the different processes and the things that they want you to go through when contributing. Things like coding styles, or if there's certain versions of code that they want used, then they'll suggest those there as well. Okay. All right, so let's go back. I'm going to just grab the main Security Onion URL. Let's say that I want to make some changes or make some suggestions to get to them as to how they can do that. What I'm going to do is I'm going to change to my home directory or some directory where I want to place a copy of Security Onion's page. Now I'm going to just clone a copy. So I'm going to get clone. I'm going to paste their URL in here. So this is going to make a copy of, well, all of the information from Security Onion's page down to my system. Now, if I was to try and make changes in this folder, right, I can now make changes in this folder, but if I was to make changes here, I'm not going to be able to then push those back up to Security Onion. Right? Security Onion has got the, just like most open source projects, they've got this thing locked down where you can't just download a copy and make changes and then push copies back up. So instead, what I'm going to need to do is I'm going to need to make a clone of that into my own GitHub repository. So what I'll do instead, I'm going to come back over here, and this little folder that I've created, I'm going to just rm -rf this Security Onion folder. Okay, get rid of that. Because what I'm going to do instead is I'm going to make a fork of this. Okay, so I'm going to take their Security Onion, I'm going to come up here to the upper right-hand corner. and I'm going to click fork. And it's going to ask me where I want to fork it to, and I will fork it to my Mark Baggett, my own GitHub repository. So this is now taking Security Onion and it's making a copy of it onto my GitHub repository. So now here, I can make changes to my own GitHub repository all day. And then once I've made my changes and I've been able to test my changes from my own repository, then I can go back to Security Onion and say, all right, here's some changes that I think you should incorporate into your stream. So we'll go back, we'll talk about that process in a moment. But first, let's go ahead and make a copy of the Security Onion fork from my repository. So I'm going to git clone, and then I'm going to paste in my GitHub repository here. Okay. All right. So now I've got in the Security Onion directory. If I look here, I've got a copy of this. Now this is a clone of a repository from my GitHub page. Now I said earlier not to worry about all of those git commands, and as you can see, doing things from the command line is a skill that I have but don't necessarily maintain, because I can look those things up when I do it, and actually a lot of graphical user interfaces are going to make these things much easier for you. So I'm going to be using Microsoft Visual Studio Code here to make some changes to Security Onion, and we'll see how the changes in the IDE are reflected by the commands that we have here at the shell. So here I'm going to type code dot. I'm going to launch Visual Studio Code in this Security Onion directory, and over here on the left, let's make this font a little bit bigger. Over here on the left-hand side, we can see all of the different files from the Security Onion folder, and I'm just going to come down here to this README file. And so here's the Security Onion README. In Visual Studio Code, you can do a Control-Shift-V, and this will this will do a preview of Markdown documents so that you can see exactly what this looks like. And this, you can see, is reflective of what we have on Security Onion's webpage when we scroll down. So here's the README that we have on Security Onion's webpage. So let's just say I want to make a change here. I want to make a change to Security Onion's webpage. I want to add something to Security Onion's webpage. So I'm going to come over here to my README, and let's add a change. I'm going to come down here. I'm going to add some information about Doug Burks is the creator of Security Onion. Doug's a good friend of mine, and lives here, lives right down the road. Something people don't know about Doug Burks is Doug is a good singer. So I'll just add that to Security Onion's repo. Okay, so now let's save this. Okay. Now when I save it, you'll notice here in Security in Visual Studio Code, over here on the left, we've got the source control tab, and here it's got a little 1 next to it, indicating that something has changed. If I come over here, it notice that, hey, README has changed. What that is showing me is git status, right? That it is in a modified but untracked state, right? So it recognizes that that README has been changed. Now, if I wanted to add that to an upcoming commit or an upcoming a commit to the web page, then I could type git add. Also in the IDE here, I can just click the plus sign, and that adds that, or moves it from a modified state to a stage state. Here, stage changes. If I come over here and do a git status, I can see that it's now modified. It went from red to a changes to be committed modified green state. Okay. All right, so I've got this thing recorded and ready to go. Now, all I need to do is commit this thing. So if I want to do that, I can do a git commit with a message, or in Visual Studio Code, I can just come up here to this messages window, and I can type add about Doug. This is the same message that I would have typed with the -m option, and I'll click plus sign, and now I've committed that. If I come back over here to my git status, I can see that my branch is 1 commit ahead, right? So I am 1 commit ahead of the remote system, right? So this is now committed this to my local computer, but it is not synchronized with my upstream connection, So if I want to do that, I'm going to have to do a git push. And let me do a git push. It's going to ask me for my username and password. And let's see here. I'm going to, let's see. I'm going to stop sharing momentarily. Or Stephen, can you pause my screen or take put me back on just a video? There you go. Thank you very much. While I type my username and password here. Okay, and leave it there for just 1 second, Stephen. All right, let's see here. All right, so you can bring back up my screen now. Thank you very much, Stephen. Appreciate that. So here you can see I just did a git push. It asked for my username, which is Mark Baggett, my password, and then it synchronized that back up to my GitHub repository. So now on my GitHub repository, on Mark Baggett Security Onion, if we come up here and we just do a refresh on my page, here I can see that my branch is 1 ahead of Security Onion. And if I scroll down here to the README, I can see I added about Doug has been just committed about 2 minutes ago. And if I scroll down in there, I can see about Doug. Doug is a good singer, has been added to my GitHub repository. Now, this still hasn't done anything with the main Security Onion repository. I haven't committed the changes there or made anything permanent. In order to do that, what I'm going to have to do is go back to the original Security Onion. And here I can see fork from Security Onion. I can just click that. That'll take me back to the original Security Onion's webpage. And now I have the opportunity to ask Security Onion to integrate this into their repository. So this is ultimately how you're going to make the changes to open source your project, right? You're going to make a copy of this on your own GitHub repository. You then pull it down to your systems. You make the changes there. After you've made the changes there, you push them back up to the to your GitHub repository. Then you go back to the original, and then we're going to do what's called a pull request. A pull request is where we say, hey, Security Onion, I got this awesome new change to your code base. You should maybe consider that and see if it's something you want to add to your repository. So I'm going to come here to pull requests. And then in pull requests, I'm going to create a new pull request. Now, initially, pull requests on Security Onion, it's going to assume that you're pulling between branches. I showed you earlier that we could create branches of code, and then you can do pull requests between branches is the default of what it's trying to have you do here. So if I want it to actually make a pull request, not within Security Onion branches, but from Security Onion to my repository, then I have to click here, this button that says compare across forks. So this little link right there. When I click that, now it's going to have, well, what's your source and what's your destination? So over here, I can say, hey, I want to pull something from Mark Baggett Security Onion. Here you can see all the forks of various security onions up in there. But I want you to pull something from Mark Baggett Security Onion. And sorry, I wanted to go to Security Onion. I want to pull from Mark Baggett Security. I want to pull from Mark Baggett Security Onion into Security Onion, right? But notice the arrow there that gives us some directions. And down here it says, hey, here's this new addition. So it recognizes what's been changed between the original Security Onion and my repository. So there's my change. What I can do now is I can create this pull request. When I click the create pull request, it's going to then ask me to give some details so that Doug Burks and the different the people that are working on this project can evaluate the code and see, well, is this something that we want to change? Why do we want to commit this change to our repository, and so forth. All right, so I'll click this create repository or create pull request, fill in the form, and then submit it. And once I've done that, right, it takes the code from my repository, it packages it up, and then it pulls it into this pull request. So as soon as the pull request is created, I no longer really need the pull request on, or the fork on my repository anymore. So at that point, it's safe for me to go in and to completely delete that fork off of it, because all of the changes and everything are now in this pull request. Okay. And that's basically the process that we're going to go through in doing that. If I come back over to my repository, I'm not going to create a pull request because I don't want to I don't want to go to Doug's head that he's a good that I think he's a good singer. So I'm not going to do this. Let's just see if I got some pull requests here associated with my account. So here you can see I've got some pull requests that I've got that I've created to some open source projects. Sometimes you'll create a pull request and it'll just sit there for months and months. Sometimes they'll never accept a pull request or even acknowledge it or ignore it, right? It really depends upon how well the GitHub repository is being maintained. So if you create a pull request and it gets ignored, you did your best to try and offer some assistance to an open source project, but the level of commitment to maintaining open source projects obviously varies from project to project, so you can't always depend upon those things to be that useful or to be accepted. Okay, and that is how we can contribute to an open source project. Are there questions about that? Anybody have questions about what we've gone through and the use of those different commands in the IDE? Looking for questions or comments. All right. With no questions, then let me show you a couple of other things here. Right, so if we look around on my GitHub repository, some open source projects for you to consider, to look at, and if you want to contribute to these, you're certainly welcome to. I've got a couple of different projects out here that you can download and begin using on these things. One of these is called SrumDump. Okay, SrumDump is a utility that is used for forensics and incident response. And what SrumDump can do is it will pull the last 30 days of process activity from your system, and then it'll create an Excel spreadsheet that shows you everything that's run. So you ever in a situation where you're sitting there and you have some process that just pops up on the system, a command prompt just comes up and goes away, and you're like, what was that, right? And you wish you had something that was logging every single process in your system. Or where I use this all the time is I get called into incident response for some company. We get there, and then you start asking for logs, right? You start trying to pull together on all of the logs they've got to put together a picture of what's happened in the incident, and the company's got very little to no logs, right? What SrumDump will do, or even better, the one that I'll use in an incident is its command line partner. The command line version of this is a tool called ESE to CSV, but ESE to CSV and SrumDump both do the same thing. On your Windows system, you've got your task manager, right? This task manager shows you all of the processes that have been running on your system. You got this app history tab, which is, I don't know, always nothing but zeros, right? It shows you the Metro apps that you got on your system. Seems like it's not very useful information, but it does tell you here that it's been tracking things, well, for me since July 13th for the last 30 days. So in the database that's associated with this, it's got 30 days worth of activity of process information. And that database is not just limited to the ones that it's showing you here, the Metro applications. It's actually recording the type of information you're seeing here: CPU time, network time, meter time, and tile update, and a whole bunch of other information for every process that runs in your system. So with SrumDump, I can go back and I can dump the last 30 days worth of processes that are on my system. And it's going to tell me, well, the user that ran the process, the amount of data that was transferred across a wireless connection, the names of the wireless, the name of the network profile that was in use, which may include wireless profiles and so forth. So this SrumDump and will create a spreadsheet that'll show you the last 30 days of processes on your system. ESE to CSV will do a command line. The reason the command line version exists is so that I can use that with something like PSExec or Cape or some other tool to reach out to all of the hosts on the network and be able to pull all of that information and give me every process that's run on every host on the network for the last 30 days, pull that back into a central share, and then go through that information from there. Okay. Another tool that's out here that you can look at and contribute to, if you'd like, is domain stats. Okay, what domain stats is this is a utility that is intended to be run in your environment along with Security Onion or some other security event monitoring platform. It integrates in with Zeek and other network defense systems. And what it does, once you installed this, and here this little video is going to show you the installation process for it. Right, we're just going to do we're going to create a little virtual environment on here, and then we're going to activate the virtual environment, and we're going to do an install from a Git page. Did you know you could do this with you can use pip to install directly from a Git page? So this will then install this domain stats project to your system. Domain stats does require that you create a directory. So here I'm creating a directory called my data, and then I'm going to initialize the my data directory and put all these settings in there. Now, what domain stats is it's a multi-threaded web server that listens for requests and then does some information gathering on the domains you give it, and then provides that back to your SIEM. So in this configuration, I'm setting how many threads I want and things like that. Like how many threads do I want the server to have running? Right now it supports, I think, well over 1,000 requests per second from your security event monitoring platform, so where you can look up these domains. Okay, and what you can then do is then you can then send queries to domain stats in order to be able to look up things about hosts. Just to give you an idea of that, let me pull up a presentation real quick. And I know that I've already gone. We've talked about our GitHub repos, and I'm kind of changing topics on you here, but there weren't a lot of questions on how to contribute to it, and I think I've covered that topic pretty well. Let me show you what we can do with domain stats. Okay, with domain stats, you're going to be able to look up things like when was the domain created. Okay, so what's the creation date of the domain? One of the reasons that that's useful is, well, baby domains, or as we call them, are typically used for phishing attacks and things like that. And so if you look at domains like Google, YouTube, and others, they've been around a while. 1992 is when Slack was created. Snapchat's the baby of the group here, and it's been around for almost 8 years now. So domains typically have been registered long before we ever hear of them. Right? Businesses struggle for years to get their domain to the point where it's something that people recognize. So if you got a domain that you're using, it's probably been registered and set up and configured and running for a long time before we ever hear of it. As opposed to phishing domains and command and control domains that are used by attackers are typically stood up and used very quickly. You might have seen last year during the pandemic, an employee at SANS clicked on a phishing link, and SANS did several disclosure webinars. And I think, if you look at all of the data that was actually disclosed, I'll say this to SANS' benefit, I don't think that they were actually required by law to do a disclosure, because I think it was just some email addresses and people's names. So there wasn't any mother's maiden names or personally identifiable information other than the email address. So in most states, it's not required that they even disclose it. But they did. They're a security company, so they did the disclosure, and they did several talks where they talked through all of the indicators of compromise and things like that were used in the malware, that did the reverse engineering of the malware, and things like that. So I took the domains that were used in that phishing scheme, just ran them through domain stats to give you an idea of what we would see from domain stats. So we look at the creation dates of those domains. Right, the attack occurred on July 24th, 2020. If you look at the creation dates of those domains, you can see that, let's see, we got June, and you also have, July 24th. Actually, just a couple of hours before this domain was used in the phishing attack, it was registered. So by looking at these creation dates, we can really do some, we can identify these baby domains, these domains that have just been stood up. So that's one thing we can do. Also, if you look at these domains, right, I know that they got a little bit of a red line here behind it, DAM. This long, random-looking host name here is not one that is ever going to be this other one. Let me just here, do this and see if I can remove that slide in. Yeah, so we can see that host name. This IWJZ, that's also a host name that is not going to be used by well, any legitimate domain. So that's something else we can look at, and it is something else that domain stats looks at when you give it a domain. So when we run domain stats, it listens as a web server, okay? And then you can take a security event management platform, and you can then every domain you see, you send it off to domain stats, and it's going to give you back a JSON response that you can then incorporate into your log monitoring platform. So if here's an example of asking domain stats, domain for google.com. I get back a couple of things. I get back a category. The category here is established. Established means that domain has been around for at least 2 years. And so it's been around for a while. It is not the other option there would be new. So I might see a new domain, something that is just recently stood up on the web. The other thing that we have here is frequency score. The frequency score is measuring the randomness of the domain name, right? So these previous domains here that are just made up of random looking characters and numbers, right? Those are going to have a much lower frequency score, right? Than these others. And frequency score is also another module that I've written and is published on my GitHub, that if you're interested in how that's working, then you're welcome to check that out as well. But it's measuring the frequency of these different domains to see, are these random looking domains? So across this established and these frequency scores, it's then going to look at those things and come up with a series of alerts to let you know whether or not this is a domain that we should be concerned about. And those alerts are going to appear here in the alerts section. Here I can see that this one is an alert telling me that this is your first contact, meaning that my organization has never queried, or no one in my organization has ever done a DNS lookup for google.com before. Right? So this was obviously a brand new install of domain stats that was there, but that's still a useful piece of information. Right? So, so by just looking at this JSON response, I can see that, well, this domain has been around for a while. This is the first time I've ever gone to it, which might be of a concern. But the frequency scores in this case are low, or are good, right? There's a threshold of these two numbers, and that we've looked at over time. And if this first number is below 5, then that probably means it's a random looking, a random host. And if the second number is below 4, it probably means a random host. So we can point various domains at it. So for example, if I go to ask it, what's the status of runcode.ninja? I can see that, well, this is my first contact to that domain, so that might be interesting, but I can also see it's established. If I make another request to runcode.ninja, that first contact goes away. So this is a bit like Zone Alarm. If you've been around for a while, remember the old Zone Alarm firewall that used to run on your system. The first time you'd ever go to a web page, it would say, hey, this is the first time you ever went for the web page. But this is not at the individual host entry. This is at the network level. We're seeing that this is the first time anybody in your network has ever gone to that domain. If we look at the domains that were used in the phishing attacks and the types of scores that we get for them, oops, here we can see that, well, for this first domain, we get a couple of different alerts. We get a suspect frequency score, meaning that, hey, this looks like random characters. Suspect frequency score means that one of the two frequency scores was below the threshold. And we get your first contact. So here I can see that, well, I've never gone to that domain before. So that's interesting. I can also see that the category is new, that this domain is brand new. It was just stood up on the network. It's not an established domain. It has not been around for a while. So there I've got 3 strong indicators that this domain is likely to be associated with some malicious activity. If we look at the other domain that we had on there, then here I can see that my alert is low frequency score. Low frequency score is worse than a suspect frequency score. A low frequency score means that, well, you've had both of your frequency scores are below the threshold, meaning that is almost definitely a random set of characters making up that particular host name. And we also get, again, it's our first contact. Nobody in your network has ever gone to that domain before. And then again, new. This is a brand new domain that somebody just stood up. So those are the kind of alerts that you can expect to get from domain stats. And again, this is a free tool. You can download this again off of my GitHub page. It's also, it can be deployed as a Docker. So if you want to deploy it as a Docker, there's instructions on the README file for doing that. But basically, you can just do a Docker build, give it a tag, and then point it at my GitHub page, and it will download and create a Docker container for you. There's some instructions that after you created that Docker, you're going to need to run it once to create the configuration file. But once you've done that, then it can run as a Docker. You can then take these platforms and then integrate them into things like Security Onion, where you've got a dashboard. So on the networks that I'm defending, I've got a Security Onion dashboard that shows me these frequency scores. So I come in here and I can see the number of suspect domains, the number of new domains, and I'm basically going to go through these and look at all of the new domains that have new domains, first contacts that have low frequency scores. If it's got all three of those indicators, then that's probably something that I'm concerned about. So we get a dashboard that's going to integrate those things. And again, the dashboard, so the basics for the dashboard itself are not published on my GitHub, but the things that you need to ingest these domain stat logs into your Security Onion platform are. Okay. All right. Here's just another look at the dashboard that we have for domain stats. Okay, so these are just some of the tools that are out there. Some other tools that are on my GitHub repository, if you're interested in them. I also have out there the 504 Lab. So another tool is 504 Lab. This might be another open source project that you might be interested in. With the 504 Lab, this is actually one of the labs that's in SANS SEC 504, where you get a piece of malware when you download, and it's malware. It's a malware simulator. Okay, what it'll do is it will you'll run a piece of malware on your machine, and it'll begin to ask you questions like, "Hey, what's the process ID of the new process that's just started on your machine? What's the parent process?" And then it'll start listening on a port, and it'll ask you to identify the thing that's listening on the port. It'll ask you to connect to the port and figure out what the banner is that when you connect to the port. So if you have incident response drills within your company, and you you're just looking to sharpen your skills that you're using to figure out what's going on with various hosts and whether or not they're infected, then this is a tool you can download from here, and then you can use it to train your incident response teams. And this is, again, a free tool that is used in SANS 504 as one of its labs, but it's a tool that you can download for free and use to train your network defenders. Okay, and that is what I got. I've got some other tools out there that that you can look at, and there's Where'd You Go. Where'd You Go is another tool that if you point it at if you give it a laptop, this one's really intended for tracking laptops and their movement across the country. So if you needed to place a suspect at the scene of a crime or exonerate someone and say that they were not at the scene of a crime, what you could do is take Where'd You Go and point it at their laptop. And what Where'd You Go does is it grabs all of the wireless networks that you've connected to from your registry, from event logs, from the SRUM, which does record your wireless networks and things like that. And it's going to pull all of that information into a database that it then analyzes and then uses various online files. So here you can see it's doing an auto acquire files. It's acquiring all of those locked registry files, the locked SRUM, and other information, pulling that information back, and then it's then going to do some analysis, figure out where they are, and drop some pins on a map to show you, hey, based upon the wireless history, we can place this person at this date and this time. Given that usually we are going to locations, we'll go to on a business trip, we'll arrive, connect to the hotel network, and then it records the first connection to a wireless and the last connection to a wireless. Usually we can put that person at a particular location for a period of time. SRUM parses data from srum.dat artifact, which is found in Windows 10, which is awesome in instances when devices are shut down. Does this artifact present or work on the latest versions of Windows. Yeah, so SrumDump will work on the latest versions of Windows. So it's been tested on all the latest versions, and it does do an auto acquire. So if we do SrumDump, when you run SrumDump, if you browse out to the directory that contains the srudb.dat file, if you run SrumDump as an administrator, when you select the srudb.dat file, if it's locked, then or if you're running as an administrator and you're trying to pull this off of a live machine, then it's going to say, hey, it looks like you're trying to get this off of a live machine. Do you want me? You can either make a copy of it, or you can click this auto extract button, and it will use volume shadow copies to extract a copy of the SRUM and then do the analysis from there. So SrumDump will work on the latest versions of 10, and it'll work on devices that are not shut down as well by automatically extracting. If you have a device that is shut down and you want to just grab a copy of that and feed it into SrumDump, then you can do that as well. Okay. All right, other questions? All right, well, let's wrap this up. Let me try and take it back home. We'll go back to GitHub and try and bring this back to my Git demo folder. So in this Git demo folder, if I do a branch-L, I can see that I've got those two branches. So when I've made my changes to my branch, and if you remember, right, Git status, I'm currently working on the master branch. If I git check out the new branch and do an ls, it deleted that file because the thing that is in that new branch, get what changed, right? It's got this thing to delete the new file. If I go back to my master, git check out master, and then I do a git what changed. Right here, I can see that this one, it does not have those other commits that are part of that that branch. Here, it's only got the thing where I added that file and where I updated the file, but there is no delete commit in this master. So if I want to now say, all right, you know what? I've made my branch. I've done all the commits and all the changes that I wanted to do off in this other branch. I've tested them. I know that this is exactly how I want my final product to be, and I'm ready to merge that information back into this. Then I think it's just git merge new branch. Yep, and that's going to take that new branch information. It's going to move it back into the master. And now git branches, git branch-L, and then git status, okay, ls. I can see that file is now gone, and git what changed, right? I can see that is now taken that information that was in that new branch. Now I could delete that that other branch and get rid of it. But that's typically how you're going to work through those changes. You're going to create the branch on your local system. You're going to then move the change, do all your changes in that branch. Once you've got that branch thoroughly tested and you've got those changes exactly how you want them, then you can move those, merge them back into your main branch, and then delete the other branches that you've done for those feature requests, and then push those things back up to your main GitHub repository. Okay. All right. That's what I've got for you today. Are there questions about Git or SrumDump or domain stats or where'd you go or freak.py that I can answer for you? All right. Hearing no questions, I think we'll wrap it up there. All right. Thanks, Stephen. I appreciate the opportunity to come on. I hope that this is useful, and I'll certainly be referring 573 students who ask these questions to this video moving forward, so that well, they'll be able to use this as a reference and how to contribute to open source projects using Git. So thanks.